Greetings to all. Today we are going to see Physics for Electronics Engineering, Unit 1, Conducting Materials. Low resistive materials are generally called as conducting materials. These materials have a high electrical and thermal conductivity. The conducting property of a solid is not a function of total number of electrons in the metal, but it is due to the number of valence electrons or so-called free electrons. Based on that, a theory has been developed known as Electron Theory of Solids. Electrons have similar behavior in conductors, semiconductors, dielectric, magnetic and superconducting materials. They also have same behavior in all applications such as computer, television, radiography, electrical conduction, etc. Thus, the electron theory of solids explain the following concepts. They explain number 1, structural, electrical and thermal properties of materials. Number 2, elastic, cohesive force and binding in solids. Number 3, behavior of conductors, semiconductors and insulators. So far, 3 electron theories have been proposed. Number 1, classical free electron theory. It is a macroscopic theory proposed by Drude and Lorentz in 1900. This theory explains the free electrons in lattice and it obeys the laws of classical mechanics. Number 2, quantum free electron theory. It is a microscopic theory proposed by Sommerfeld in 1928. This theory is explained with the concept that the electron moves in a constant potential and it obeys quantum laws. Number 3, Brillouin zone theory or band theory. This theory is proposed by Bloch in 1928. It is explained with the concept that the electron moves in a periodic potential. This theory also explains the mechanism of semiconductivity based on the bands and hence it is called as band theory. Now we are going to see the classical free electron model. The principle is, according to this theory, a metal consists of a very large number of free electrons. These free electrons can move freely throughout the volume of the metal. They are fully responsible for the electrical conduction in the metal. After the discovery of electron, Drude and Lorentz attempted for an explanation of electrical and thermal conductivities based on the assumption that the metal contains a certain number of free electrons and hence they are called as free electron theory. Postulates of free electron theory. In the absence of electric field, when an electric field is not applied, the free electrons move everywhere in a random manner. They collide with other free electrons and positive ion core. This collision is known as elastic collision. The diagram 1 shows the elastic collision between the free electrons and positive ion core. The free electrons move randomly in all directions and hence the potential energy is 0. The free electrons collides with each other and with the positive lattice elastically without any loss in the energy. In the presence of electric field, the electrons are assumed to be a perfect gas. So they obey classical kinetic theory of gases and the electron velocities in the metal obey the Maxwell-Boltzmann. When the electric field is applied, the electron gets some amount of energy from the applied electric field and they begin to move towards the positive potential, that is in the opposite direction to the applied electric field. Here, drift velocity plays an important role. Drift velocity is nothing but the average velocity acquired by the free electrons in a particular direction due to the application of electric field. It is known as drift velocity. Thank you.